You are welcome to today's class. In this video, we'll be talking about the position of a resultant force. So we are given a body with four forces acting on it at different angles. So the question says, find the position of the resultant force of this shape. So to start with, let us note all the forces that we have. We have 18 kilonewton acting at 135 degrees from the horizontal. We have 20 kilonewton acting at 120 degrees also from the horizontal downward. We also have 10 kilonewton coming directly from the center of the shape acting downward. Then we also have 12 kilonewton at the point A acting upward. So these forces, we are going to find the resultant force and determine the position at which the resultant force is located. To start with, we can have the shape in this form. It's still the same shape we are having here, this shape. So we are trying to transfer it and simplify it so that it can be easier to solve. So you can see that of the 18 kilonewton has been changed into something like this. So we have to form a triangle out of all slant forces. Now look at that of 20 kilonewton as well. So we also have to convert it into a triangular form. So which is this. So also we can also deal this issue in different way. By what? By forming a force in a way that they will all meet at a point. So looking at it like this, so you can also resolve it. You can also solve it in this format. So this contains the whole forces from the 12 kilonewton, the 10 kilonewton, the 20 kilonewton, and the 18 kilonewton. All the slant forces we have to form a triangle from all slant forces, showing the direction of the force. Now let's start with this. You can see that this 18 kilonewton is having an arrow pointing inward. So this is the force in this direction. So the two forces that we are going to obtain from this slant force, which is the vertical force and the horizontal force, the arrow must move in a direction opposite to the resultant here, because this is the resultant of these two forces, this 18 kilonewton. So then after forming a triangle from it, you know this is 45 degrees. Then the opposite of that 45 degrees is going to be 18 sine 45 degrees, and the adjacent is going to be 18 cos 45 degrees, which is also the same thing with that of 20 kilonewton. We also form a triangle from it. So the side facing the angle is 20 sine 60 degrees, and the adjacent side is 20 cos 60 degrees. All these have been explained in our previous video. So even to get the resultant force should be easier if we have been following the previous video. So now the first thing we are going to do here is to determine the resultant force. So how do we go about determining the resultant force? So this will take us to the next page of this class. Now, solution. Don't forget we have conditions when dealing with equilibrium, which are the vertical force, upward vertical force should be positive, and vertical force that are moving downward should be negative. Also, force that are moving to the right should be positive, while those that are moving to the left should be negative. So then the next thing we are going to do here is to find the algebraic sum of all vertical force. So we are starting with the 12 kilonewton force. You can see it's pointing upward. So far it is pointing upward, it means it will be positive. So we are dealing with all vertical force. These are vertical. Any force in this plane, we consider them as vertical force. So we have 12 kilonewton, we have 10 kilonewton, then we have this 18 sine 45, then we also have this 20 sine 60 as our vertical forces. Now looking at this 12 kilonewton, we can see that it's going upward, which is the reason why we have it to be positive here. Then we go to the next, which is the what? 10 kilonewton. We can see that our 10 kilonewton is pointing downward, which is the reason why we have it to be negative here. So we have 12 minus 10. Then we go to our 20 kilonewton. So we can see it here. This is our 20. We obtain it from this 20 kilonewton. So the opposite side of it is vertical. So which is 20 sine 60 degree. So then, since it is downward, we have it to be minus 20 sine 60 degree. Then the next one, which is the what? Which is the 18 kilonewton. You can see the 18 kilonewton here is also pointing downward. So, which is the reason why we have our 18 to be what? To be negative. Yes, our 18 is negative. So, sorry, from this point, I'm supposed to change it to negative. There's a mistake here, sorry. So this should be negative, which is what I've done here. So, finding their value, we have this to be 12 minus 10. 20 sine 60 is minus 17.3205, and this is going to give us minus 12.7279. Don't forget to change this to negative. It's a mistake. So when you add the whole values together, we have this our sum of vertical force is going to be minus 28.0484 kilonewton. So then we do the same for our horizontal forces. So sum of all our horizontal forces. So we can see we only have two slant forces here, which is that of 18 kilonewton and that of 20 kilonewton. So then it is only these slant forces that we have horizontal, because all this 12 does not have and this 10 does not have it. They are only vertical. So we are going to get horizontal from these two alone. So which is this 80 cos 45 and what? This 20 cos 60. So which is the reason why we have it like this. So our 18 cos 45 is positive, and also 20 cos 60 is also positive. From our diagram here, you can see they are both going to the right. This arrow shows that it's going to the right. This arrow shows that it's going to the right. So I believe we already know how we obtain this arrow. We have explained that in our previous video. So then we have our horizontal force to be this, which is 18 cos 45 to give us this, and 20 cos 60 to give us this. So our value is 22.7279 kilonewton. Then after that, we find the resultant force. To obtain our resultant force, we already know the formula, which is square root of sum of all forces in the vertical square, and square of sum of horizontal force. So our vertical force is minus 28 from what we have obtained here. the square, and our horizontal is this. Then when you have the total, when you do the calculations, you have a resultant to be 36.1008 kilonewton. So we have obtained our resultant force. Then the next thing is for us to move to how to determine the position of this resultant force. So in order to do that, we move to the next page. But before we move to the next page, we should remember that the whole diagram here, the whole forces here has been converted to something simple like this. So we have the vertical force, we have the horizontal force, and we have the resultant force. So to determine the angle at which the resultant force make with the horizontal, we already know how to go about that, which is our cos theta equals to opposite over hypotenuse. This is what? Sorry, we are using our cos, which is the adjacent over hypotenuse, which is 22.7279 all over the resultant. So from there, we obtain our angle to be 51 degrees. Now, to determine the moment, or let me say the position of our resultant force, we are going to take moments of all these forces and the acting that is acting on this shape. So to do that, we also have a condition to follow here, which is what? Moments. We are taking the moment, the moment we are taking is going to be about A. So we are taking moment about A. So in order to take moment about A, we have to follow the two conditions, which is moments that turn the shape clockwise should be positive, while the one that turn the shape anti-clockwise should be negative. So what do we mean by that? Okay, let's start with resolving the one of vertical first. All force on the vertical, we want to find the moments of all force on the vertical. So now let's check all the forces that we have on the vertical. These are vertical. These are vertical. Let's use this. This is the point A. We want to take moment about this point. So what do we mean by taking moment? It means that we assume the force here is moving to this position. So meaning that we are considering the force and we are considering the distance at which this force is situated from A. Now, this 12 kilonewton is already on this position, so it has no distance. That is why we have it to be this 0. So it is 0. Now look at it. Then we'll go for the one of the 18. Look at the 18 here. The distance at which the 18 is to A is 3 meters. So now let's get the vertical force here, which is this. You can see the vertical force here, which is the 18. The vertical force here is 18 sine 45 degrees. So it's moving in this direction. So, but before we know, we have to determine the sign first. Now look at this arrow. Consider the arrow is pointing downward. As it is pointing downward, it's going to rotate this thing downward. Let's assume this place is fixed. If this place is fixed, what happens? If this place is fixed, what happens? And we are applying force in this direction, meaning that this will rotate anti-clockwise. So far is rotating anti-clockwise, and our condition says whenever we have anti-clockwise rotation, the moment of that force should be negative. So meaning that we are going to have minus 18 sine. You can see it here. We have minus 18 sine 45 times 3 because of that distance. You can see 3. Then the next one is 10. Now let's look at the 10 here. You can see 10. It's also vertical. You can see it here. For it to move in this direction to this position of A. So we have here to here. Look at it. Here to here is 2 meters. So meaning that's going to be 10, and you can see it's also trying to rotate it anti-clockwise, meaning that it's going to be negative, which is minus 10 times 2. You can see it here, minus 10 times 2. Then we go to the next one, which is the what? The 20. You can see the 20 is also moving downward. 20. So here, this is 20. If this force acts like this, let's assume we draw the force like this. What happens? Because this place is fixed, it's going to try to rotate it in this direction as well, which is anti-clockwise as well, which is the reason why we also have minus 20 sine 60. In what position? Now look at it, is here. Here to this place is 1 meter, which is why we have it times 1. So if you do the calculations, you have the moments in the vertical direction to be what? Minus 75 points this. Then for horizontal, this is the horizontal of point A. So we want to move our forces to the horizontal. Don't forget we have just two slants that will give us horizontal, this and this. But this will be 0 because the horizontal of it, which is this 18 cos 45, is still on the same plane as the A. There is no distance covered. They are still on the same plane. Okay, let me use this. You can see the position of A, the horizontal, that is the same plane. So which is the reason why we have it to be what? Which is the reason why we have it to be 18. It can be plus, can be minus, because on that plane we can't really say if it's going to turn it clockwise or anti-clockwise. So we have it to be 18 cos 45 times 0, no distance. Then the second one, the second force, which is that of 20. You can see this is it. 20 cos 60, this direction. This is it. It's also mean that we are drawing this thing in this direction. The force is going to rotate this anti-clockwise. And year to year is 1. So which is the reason why we have it to be, sorry, this is we are determining the horizontal. This is the horizontal. So year to year is 3. So which is the reason why we have it to be 20 cos 60 times 3. So when we add this together, we have minus 30 kilonewton meter, which is the unit of the moment we are taking. So total moment is going to be the sum of this, the one for vertical and the one for horizontal. We have to consider the signs. So which is minus 75.5043 minus 30. So we have our total moment to be this. Since we have our total moment to be this, don't forget the formula for moment, which is moment equals to force times distance. And this is the distance, the position we want to determine, which is what? In moment all over force. Then our moment is this. The negative is not necessary here. The negative is only telling us in the end where the body will move to, how it will rotate. So our moment is this all over the resultant force. So we have our position to be 2.9225 meter, meaning that the position of the resultant force is going to be from here, when you measure here to the distance, which is 2.99, somewhere here is where our resultant force will be located at an angle of what? At an angle of, I believe we have obtained the angle at an angle of 51 degree. You can see angle of 51 degree. So if we are to position it, it's going to be at an angle of 51 degree. And also remember that our what? We have the sine part. This is always the sine part to be negative, and we have the cos part to be positive. In our 4 cardinal points, remember that in our 4 cardinal points, we can only have negative sign and positive cos at what? At the fourth part of the triangle of the 4 cardinal points. Don't forget that. So definitely it's going to be the position of the resultant. If we are to do it in this format, the position is going to be in this plane. This plane. This is the position you are going to have a negative sign and positive cos based on what we obtained in our calculation. So our is going to be in this position. The resultant force is going to be in this position. So at what? At 51 degree. So that is if we are to use this diagram. So on the main shape, don't forget the position is going to be somewhere here. So this is how we calculate the position of a resultant force. Thank you. We shall meet in our next class.